Hi, everybody. Mary here, and welcome to week 10 of our course. And we are going to talk this week about different kinds of chemical reactions. Here's our story so far. Last week, we were worrying about writing and balancing chemical reactions. And if you remember, a chemical reaction, it's a recipe in chemistry. It tells us the ingredients. It tells us what things are you start with, what do you end with. The special instructions can go above that yield sign. Do we have to add heat? Do you have to shine light on it in order to make things go? If we use those coefficients and we use those and translate those into moles, we can ramp it up and make a big batch or a little batch. What we're going to do this time is we're going to talk about different types of reactions. As we think about these types of reactions, I want you to think about them sort of like types of goods you can cook or type categories in a cookbook. Now, there are millions of different kinds of chemical reactions, and human beings, we categorize things in order to simplify. If we are overwhelmed with too much data, if we can put them in different piles, it makes life easier. It helps us figure out what's going on. So with chemical reactions, if we can categorize them, it helps us recognize similarities. If we know what this kind of reaction does, we know what similar reactions are going to do. We can predict the outcomes. Also keep in mind as we go through these that many reactions are going to fall into more than one category. And some of the reactions we are not going to talk about. There are many reactions in the world that are very complex, and those very complex reactions are beyond the scope of our course. And so this is a basic chemistry class. We're just not going there. We are going to look at 6 basic types of chemical reactions. The 6 we're going to look at are synthesis, decomposition, single displacement, double displacement, acid-base, or basic combustion. Now, there might be slight variations in these names. Some people call single displacement single replacement. Some people call double displacement double replacement. It is okay, you can call them one or the other, but the chemistry is still the same. And as I mentioned a minute ago, many reactions can fall into more than one category. And again, I'm going to use a food analogy. If these were the different tabs in a recipe book, if you had a lovely salad like this and it had a wonderful grilled chicken breast on top, it had some eggs, it looks like there's some wonderful bacon there. For me, I would treat that as my main dish or my entree, but it also is a salad. So where do you put it in your recipe book? Well, it kind of depends on how you're looking at it. Chili. I love chili. When I make chili for my family, I treat it as a main dish. I don't treat it as a soup, but some people might file it under soups. Cinnamon rolls. Well, cinnamon rolls are definitely a kind of bread, but I could eat cinnamon rolls for dessert. I love cinnamon rolls. So there are variations in the categories of chemical reactions in the same way that there could be variations in how you categorize food in your recipe box. It just depends on how you look at things. First kind of reaction we're going to talk about is one called synthesis. When you synthesize something, you make something. And a synthesis reaction is also called a combination reaction. This is where you make one product from 2 or more reactants. Every reaction I give you, I'm going to give you the generic form of that reaction. And the generic form for a synthesis reaction looks like this. You have 2 compounds, 2 things that come together. A plus B give you AB. So how do you recognize a synthesis reaction? Well, it's pretty easy. If you have one product, you have a synthesis reaction. This is a classic example of a synthesis reaction. If you take a piece of magnesium ribbon, magnesium is an element. It's a soft, shiny alkali earth metal from group 2 on that periodic table. And if you take that alkali earth metal and you burn it in oxygen, it produces a beautiful bright white flame. And in that burning process, you create magnesium oxide, which is a white powder. This is a classic synthesis reaction. How do you know? Well, you've got multiple things come together and you have one product. Classic synthesis reaction. And this is one of my favorites to do in lab because amazingly, you start with a piece of magnesium, you weigh the ashes that are collected afterwards, and cool thing is the ashes always weigh more than the actual metal because oxygen molecules have been pulled out of the air and have been bonded to that magnesium. It's just so cool that you burn something and it weighs more after burning than before. Another example of a synthesis reaction is sodium plus chlorine gas to produce sodium chloride. We've talked about this reaction many times in the course. Again, how do you recognize it? One product. Multiple things come together to produce one. That soft group 1 sodium metal, that toxic, nasty chlorine gas, and lovely sodium chloride that is essential for life in small quantities and make French fries extra yummy. The second kind of reaction we're going to talk about, this is our second type, is decomposition. Well, when something decomposes, that means it's going to break apart. And a decomposition reaction is going to involve one reactant that is converted into 2 or more products. The general format is going to look like this. AB is going to decompose into 2 or more other things. How do you recognize a decomposition reaction? That one's pretty easy too. You're going to have one reactant. You're going to have one thing on the reactant side of that yield sign. Now, decomposition usually needs something to get it going. So it usually is going to involve a little energy. And that energy is going to come often in the form of heat, light, or electricity to kick that reaction into gear and make it happen. Classic example is hydrogen peroxide. Hydrogen peroxide is stored in brown bottles. Why? Well, light has a tendency to decompose hydrogen peroxide into water and oxygen gas. If you have a wound and you pour hydrogen peroxide on it, there are enzymes in blood that will decompose the hydrogen peroxide, and that enzyme is going to go right here as a catalyst to make that happen. We'll talk about that in a later talk. But that is going to produce plain old ordinary water and oxygen, and the bubbles you see there are the oxygen, and the oxygen is the disinfectant that is going to kill the nasty little bacteria in your wound. Here's probably my all-time favorite decomposition reaction. And that is the decomposition of baking soda when you cook something. Now, many people don't think about this reaction. They just look at their cookie recipe or zucchini bread recipe and they add in baking soda. But when baking soda is heated, when you add a little flame to baking soda, what happens is it will, with the addition of heat, it will decompose into a gas of carbon dioxide, water vapor, and it will leave a solid of sodium carbonate behind. Now, that carbon dioxide and water vapor gas, you can witness what it's doing because as those cookies decompose, they go from being little lumps of dough to having little fluffy pockets of air, and you can see those little fluffy air pockets. They are what make your cookies light and fluffy. And that is what makes your cookies rise. It is not yeast that you're using in cookies. It's plain old ordinary baking soda. And that's where the gases come in to give you those air pockets in that food. The sodium carbonate, if you're using a small amount of baking soda and it's distributed well within your food, it's not a big deal. If you have a big lump of baking soda in your food and you don't stir it well, you can get a nodule of this. I've gotten it in zucchini bread. I've eaten it a few times. and it doesn't taste very good. It's kind of bitter. So if you use baking soda as a raising device in your cooking, make sure you stir it in pretty well. Otherwise, you get these little bitter lumps once in a while. Okay, those are our first two kinds of reactions, and we will come back later with other kinds in our next talk. Bye-bye.